Hello, Copenhagen. Hello. I'm excited to be here because I'm obliged to say that at 11 in the morning. Welcome to my talk today. My name is Heather Downing, and if you would like, I have got a lot of information on these slides. I'm going to give you this first. So I figure if everyone takes a picture now, you can always delete it later. And this is where you can download the slide deck for later. Fair? Awesome. You're probably wondering who the heck I am, and this is my obligatory slide telling you that. My name is Heather, and I do a lot of things. I've done a lot of things for about 15 years in tech. Recently, I've got into the startup path after years and years being an employee of someone else, specifically to build a lot of Fortune 500 and 5,000 apps. So now, why this talk is relevant is because I am currently going through the pain and suffering that is deciding what to do when you're building an app as a mobile platform B2C. Now, I'm sure you know what that means. To the regular masses, the people who are not technical. I got spoiled for a while just being able to work on projects that people like you all would be able to be involved with. But this one is different. So I decided to put together a map years ago about this, and for the first time, I'm actually rewriting it and looking at all the things I think are important. It kind of goes like this. This is like a David and Goliath theme. You being David, the app being the Goliath. So there's going to be some pictures. That's your comic relief, because I'm not a very funny person. But the first thing we need to know when you walk away here is like, what is your desired result? Then we're going to pick your poison, pick your tech poison, what stack you want. Then we're going to divide and conquer, hopefully your code. We're going to defend the castle, although that's more like I think, Dali's version of Risk there, a little bit more ancient version. And we're going to find the weakest links in this process as you're building your mobile app. And hoisting the publishing colors. This is probably one of the most exciting points of your development cycle. And I'm going to give you a gift. I wrote this about 7-8 years ago, and I, in Microsoft Paint, drew out this flowchart diagram, a decision tree, that has finally been updated. You're welcome. And then, of course, I'll give you some parting advice. I'll tell you how to make these decisions from the beginning through ideation and then going to the end. So now, while there's not going to be any code as part of this, I argue that the code is honestly like an implementation detail at this point. When you build for mobile, it is a paradigm shift from the world of APIs that I came from. So come with me and we'll start. What is your desired result? What kind of end product are you aiming for? I know what you're thinking. You just want to create the best mobile app ever and dominate the competition. I mean, of course you do. You want to be the best. We all want something to work well and make us proud. But in the real world, things don't go as planned almost any of those times. So let's do a quick poll. Who here has been coding for less than 5 years? A couple of you? Great. How about more than 10? A bunch of you. Great. For those in the middle, you guys know just enough to be dangerous. And those are my favorite kind of people, because you get to experiment more. You're trusted just enough to be able to build from there. We might have great ideas, but when it comes to results, we need focus. And those of you who have much larger experience know what we're talking about. You have to figure out what you're building. Is this a game? Is it going to be a forms-based application, nice and boring? Is it going to be government regulated? Not so fun. The more specific you can be about your end product, the better equipped you'll be to make the right decisions throughout the process. Now, if you're not the one who gets to make the decisions about what it is you're building, and there is a separate product owner and person over here, or maybe someone that's hiring you that just says, I want you to build this thing for me, it may take several sessions to kind of wrangle out of them what they're actually wanting more than just a feeling. Sometimes it takes a bit of time. What we envision in our heads isn't always what ends up happening. In fact, I'd argue it never happens. I think I can build this app. This is what the architecture will be that I will use. But the brilliant part about what makes us architects is that we have a lot of introduced, what is that word? We have a lot of introduced restrictions on what we can choose. Perhaps you can choose this, but not that because of X. Take a good look at the options. Consider your target audience, your data needs, and your overall goals. So the clearer you are, the better your result will be. So there's a saying, what gets defined gets measured, which is nice and boring and makes great JIRA tickets. But we kind of need to do that as architects. Define your target audience, specify your core functionality. You have to establish those performance targets, and that can be both performance of the app and the performance of your team. You got to prioritize your user experience in ways that you never did before, unless you were a web developer, in which case you've always done that. Ensure platform compatibility as well. If you're a solo developer, you have the luxury of making these decisions by yourself. But if you're part of a larger team, don't be afraid to speak up really early with your ideas. It doesn't really matter what level you're at. By contributing really thoughtfully to these discussions, then you'll quickly become seen as an expert in the process just by asking the right ones. The key is to be specific and focused with what kind of mobile app you're building. So this isn't just about making an app, it's about defining its purpose. So in my case, this is a B2C app, or consumer deployed. And that becomes important to know because B2B mobile apps can often be deployed differently. Has anybody here deployed a mobile app not through one of the app stores? Okay, a couple of you. So you know that that is an option for you. However, if I were to build this, and I'm going to use my app constantly as a good example because it's right on my mind, the users that I'm going after would not trust my app if it was downloaded from some random site. They want to go through the Play Store or the Apple App Store. They want to do that because it's seen as an area of trust because Apple and Google have looked at it. The bad thing is Google and Apple have looked at it, which means that they have a lot of opinions about what kind of security practices they want you to do, and sometimes nothing to do with security practices. Sometimes it's just, we don't want you to build an app that competes with something else that we have, like our Apple Watch faces. The next thing you got to look at is if you're going to make this a self-contained or service-driven app. My opinion, very strong, is that you don't need a mobile app unless you need offline functionality. Just saying. Not that you can't also kind of do a little bit of that with some fanciness with PWAs, but if you're building an app that is literally useless unless you're constantly connected to the internet, why is it on there? There could be a couple of reasons why. But in this case, maybe you want better performance, like for a game. Then it makes a lot more sense to do that than try to stream things over a progressive web app, right? But not always. A lot of things are being done better. The next thing you need to think about is where you're going to store your data. Do you want to store it locally, always? Do you want to always have it live on a server? That's usually the way that I have approached it, is that it lives somewhere else because you never know if somebody's going to lose their phone and re-download their app and need to resync. But that doesn't make any sense for a calculator app. It just doesn't. So all that needs to be is just locally stored, maybe in a SQLite database right to the device. Has anybody here never done mobile apps before? Cool. So everybody is an expert. Why are you here? I know what you might be thinking. These are basics. Yes. There's a lot to wrangle. I came from a world that was just APIs. I built .NET APIs for years. And then I built a progressive web app before it was called a progressive web app as a presentation for my internship probably close to 14 years ago. And it has changed dramatically since then. So now I've spent all this time in this space. You just need to focus on what your end product really is, and then you can go backwards. The reason that this is interesting for me is that data can be cheap, depending on if you're hosting it in your own server in your house somewhere, or it could be cheap depending on which host provider you choose. When is that not cheap anymore? When you're doing a lot of it, when you do a lot of data. And in games, that happens. It doesn't necessarily happen in the way you'd think, but it can really happen. So sometimes, when it comes to what I'm building, which is in the fintech space, I want to make sure that I can limit the amount of noise that's going overhead. Here, you guys have pretty good internet, right? I live 23 minutes north of my airport in Kansas City, Missouri. And that sounds great. But it took years for us to get fiber internet a little bit faster. And just 5 minutes away, people had almost no signal. It was very slow. So nobody could play Pokemon Go very well because it was just so sluggish. There were very chatty API calls from the app, and so that was just something that people had to start considering. How much of the engine can we put and ship with the app? That's good for offline functionality. The trade-off is space on the device. And if you're like my mother, she has never deleted an app that she's ever downloaded, and everything is still on there. So remember that when someone downloads it, it's jockeying for position. They're also constantly watching how much memory is eating up, how much battery it's eating up. There's always going to be a trade-off with whatever you try to do. This is a popular one. You have to consider the market share when you are building this. Globally, 71% of users are on Android. And that kind of surprised me. And these are new stats that I pulled out again. It was a little bit less than that when I last looked at it. Media loves Apple products. So that's always what you see whenever you're looking at an influencer. They usually have one of those. They say everybody has an iPhone. iPhones are very expensive. In many countries, Android is the only option because they can get much less expensive models there. Most people have an Android phone, and a lot of this has to do with globalization. So when you're deciding, well, who's going to be using this, you have to also look at countries. For what I'm building, this is going to be based on an open banking API spec, which means multiple countries I'm going to have to support. And in fact, because of the crossover nature of what I'm building, I might get more adoption in a developing nation, even than in my own country at first. So instead of saying, I'm going to launch with the iPhone app first, I'd have to really consider launching them together or starting with Android if I was going for a global approach, which means that's the order in which you prioritize your Jira tickets. Worldwide, they've kind of gone up and down a little bit. It's really interesting to kind of see how much Android has dominated since 2012. But in my country, in the US, as of February, iPhone is leading by quite a margin. But we are a wealthy nation, and most people can afford to buy an iPhone, even in middle class. And so that means if you're only launching in my country, maybe you would start with the iOS app. And that's why, frustratingly, sometimes when somebody tells you that they've got a solution, it often will only be supported on iOS at first and take a long time to come over and port to Android, which is a very different chart, just looking country by country. And so I was wondering, well, what does that even look like with other countries? Apparently, Spain really loves Android. So if you're going to be building something for folks there, you have to kind of lead with that. Or you can launch them at the same time. That will take you just a little bit longer initially up front. So sometimes either the constraints that are given to you by the company you're working for or by the nature of what you're doing might require a little bit of market share look. Another thing that you might consider is the app is free. Ours is at a freemium level, but which platform do people spend more money on? We kind of know that answer just by nature of what device they have. So if this is something that you're launching that is going to be a paid app, maybe that's another reason, regardless of country, why you might want to launch iOS only. At this point, I think forecasted for this year, 124 billion is the spending for iPhone users, and app spending amounts is 51 billion on Google Play. But Android apps are 3 to 4 times more likely to have ads embedded in it because Apple doesn't like that. So even though that's just in-app purchases directly through Google Play Store, remember there's going to be a whole bunch that go right outside of that store. So right now, I have a fantastic, nice, expensive laptop, but most people don't. And so when you are designing, most of us are designing mobile first now. Yes? If it is a publicly facing app, for sure. But oftentimes, if we're doing an internal app, we just build sites that are not progressive because everybody at that job will look at it on a desktop computer or a laptop computer. But increasingly, that is not the case. Even for the things I'm building, I'll often pull it up on my phone while I'm on the go. So at this point, mobile first should just be the default. And luckily, there's plenty of frameworks that can help you with that. But that's just something to consider. Most of the companies that I've worked with did start their mobile first strategies 8 years ago. Maybe half of them have done it. So there's plenty of work for us all still out there if you're interested. All right, now we kind of have the overview. We're going to pick our poison. Which one do you launch at it? How much time do you put into bugs? What's the ratio of that technical debt to new platforms, to like the new features on the platform? It's important to always look at the realistic approach. So let's talk about native. This one is probably most of my friends' favorite, and it has gotten somewhat easier over the years, but it still is a separate approach. If you're going iOS, you're looking at Swift development using Xcode. And a heads up, you'll need a Mac for this. It's non-negotiable. For Android, you're dealing with Kotlin or the JVM if you're looking at porting older versions of Android. With Android Studio, you can also use Eclipse, bunches of them. So the nice thing about Android development is you can do it on a Windows or a Mac. Yay, it wins. At my previous company, we had a big team doing native development. There was like 10 of us. And there were some iOS developers and some Android developers. I was the one brought in to help build lightweight APIs between the really big, bulky ones that would just be the use case only API calls that the mobile apps could call, so they wouldn't have to make this a huge tree of calls back to like the main API, so I got to build a nice lightweight one for them. And then, of course, because I built APIs in .NET, I had experience with C#. So then they're like, great, you should come do mobile. So I had to learn native with them in addition. And let me tell you, back then, Swift was a baby. I had been doing Objective-C for a year and just ported over to Swift, and it was still this much code to just do an HTTP call, like back in the day. It has thankfully improved immensely. The good thing about this is that we had specialists in knowing the idiosyncrasies of each of the OSs. And you can do that yourself. It just takes a little bit of time to really wrap your head around it. Yes, it is duplicating work technically. But there are some serious pros to this approach. Oh, I guess I didn't hit that button. Sorry about that. So let's talk about the pros. First off, you get a natural development cycle. So everything is supported, documentation is easy to find, and Apple and Google provide detailed tutorials. It's straightforward, which is also nice. You get full access to the libraries and the hardware features, and this becomes really important with new releases that support new kinds of hardware that has new sensors that have never been used before. And of course, offline capabilities and much tighter security compliance because it's native. Another pro is a natural publishing cycle to the app stores. It's all very native. It's the way it's supposed to be done. This is the way. I say better loosely because you're still going to deal with manufacturer upgrades, but at least it's all in one ecosystem. Backwards compatibility is usually handled somewhat, again, natively, because they're like, well, these features are covered here, these features are covered here, and you can call these things this way, and then you can still install your app on devices that are older. It's easy to kind of navigate through that documentation. But let's not sugarcoat it. There's some significant cons to this approach, because the learning curve is pretty steep if you've never done these languages before and you never thought in these languages before. If you're a solo developer or a weekend warrior, you're looking at learning like multiple environments, languages, operating systems, each with their own quirks. And it's going to just take you a lot longer to launch this to market, especially if you're new. Or even if you know one really well and you're learning the other, let me tell you, whatever t-shirt size you're giving, it is too small. It can also be really costly, whether you're paying for courses on platforms like Pluralsight or using a third-party services to offload some of the work because you don't know specifics. There's often a financial investment involved with learning both. And here's the big one that really gets me, is code duplication. I hate it. So I don't want to have to do the same thing. That is like the number one place we would find bugs was not that it didn't work, is that it worked differently, or it didn't look the same as the other version. Now, aspects, of course, to these OSs are going to be a little different, usually in gestures and menu navigation, but that's usually about it. Some of the look and feel should be pretty close to the same, especially if you have a good designer. They're going to give you really good resources and assets to be able to slice up. But I don't like to repeat things, and so whenever possible, this kind of gives me a big con, having done this approach myself. So that leaves us with the cross-platform compiled approach. Whoa, the big one. So that's the promise of writing once, running anywhere, reducing your development time, etc. That can be true, and I found that there are just a lot of options and it's hard to sift through. So when someone says, yes, I use this framework, there's a lot of nuance in that statement, because they may have chosen that framework not because it was the best one of all time, because it was the best one for their constraints, or what their team knew in terms of programming languages, or what their team had built, and how complex their app is. So you'll find that that most of these frameworks will work for one use case or another, but it may not be the one you're looking at. But cross-platform is growing in popularity. For a while, it was just native and like the WebView hybrid approach, and now cross-platform has been growing and growing over time, and now it's about 28% market share. And when I say cross-platform compiled, meaning that you write it in the language that you want to write it in, and then it is compiled down to binary and will run natively on each of the OSs. But the management of the code is something that you can do together, which arguably is the thing that is difficult. In theory, you should have access to every library with this approach. The beauty here is that you can code in your language and you share the same code base. You'll typically work, though, with a custom IDE or IDE plugin. You can develop on Windows or Mac, but remember, you're going to need a Mac for building iOS files. We'll get to more about that later. It's a bit of an if-else situation that we have in the process. This approach is really powerful because it facilitates sharing your data and your business logic. And in my case, I was able to, in the same project, also put my little lightweight API. So if I wanted to really put it together, if I was just a solo developer, that's easy for me. Now, how many of you are a solo developer and you work by yourself? Great, so you're all a team. Cool. So then it becomes more important maybe for you to break out those projects just for management so you don't have to wait for it to load every time, right? For a project you're not working with. You can separate your UI layers too, which you absolutely should do. I know this isn't a design class, but trust me on this, you want to always separate your UI whenever possible. The good news is that it shares the majority of the business code and usually ports any changes into a new DLL for you. It allows you to code using the libraries in one language base and often provides support via community and software staff resources. It can be invaluable when you're stuck on a problem. I find that in mobile development, we, the people, are the ones who are the support. Because mostly we run into similar situations and use cases that for some reason never get into the documentation for any of these frameworks. So really embrace the community aspect of this and you'll go pretty far. The cons to this, though, is that it can kind of be expensive sometimes. Some tools like Maui and Xamarin have free options. Enterprise-level work often requires a paid license, depending on the type of app you're building or how many users you're going to have. This can be kind of prohibitive if you're a more small team. It also requires more work than write once, code everywhere. It is not true, but it is mostly true. Just to give you an idea, I love that phrase, but it really is mostly for show. You can't just write once and expect professional level results across the platforms. You can do some really simple basic things and it will proliferate. If you have no opinion on UI design at all, then you can do it. And maybe that's all you need for something that is a short-lived application. But usually we're building something nice and fancy, aren't we? There's also added complexity in setup and publishing. When I first started with Xamarin, it took me 2 days just to set up the environment. So that was a little bit longer than what I was used to. It's better now, but it's still an extra layer to consider. Lastly, there is what I call the widespread recipe problem. Instead of having all your documentation in one place, you're often hunting across Stack Overflow, asking your AI of choice, searching forums and blogs. And if you're from the Java world, anybody? No? If you're from the Java world, they're used to this. But coming from .NET, where everything's neatly on Microsoft's site, it can be a bit of an adjustment to be looking outside of that. In the end, you have to kind of decide what approach you're willing to invest time in. Each has its trade-offs, but understand these can help you make the best choice for your project. And the next app you build, this may not be the right choice. Here's the newer comer to the landscape, and I thought that they had a really nice diagram kind of showing a little bit of an example about how much you need to consider where things live. So I've already mentioned some of these examples, but .NET and, of course, Flutter, React Native. The reason I bring these up is that they're not traditional native languages for mobile, except for Kotlin, which, of course, is the last one. But it's cool that you can actually write in Kotlin also for iOS now. And that's what our friends at JetBrains did. But, of course, I think this order is not necessarily in their popularity. It was just the order I dropped it in. There's more in PHP. There's one in C++. There is, obviously, Rust is coming for Flutter. So, there's a bunch for Python. Depending on whatever you come from, there's probably a cross-platform compiled approach for you. These are actually pretty good, and they work really closely with Apple and Google to make sure that they know what's coming out next and they're ready. Because a lot of times frameworks are measured about how long is it going to take from the time that natively I could have put this in my app to when I can put it in with Maui. How long is that going to take? Microsoft has made it a lot shorter time frame than others because they have a dedicated team. Sometimes these are just open source, and it's somebody's time for free that they're doing. So just keep in mind that you may really love a framework for this, but maybe you won't have access to that cool new sensor on the iPhone for like a year if they just didn't get around to putting it in their platform. Okay. But let's say you're not really willing to commit to that much of a setup time. Maybe you want to do a really quick version of an application, especially when it's something that's time sensitive. In my case, I used to work in an innovation lab where the average time I got to build something was 6 to 8 weeks. And often it was for something like, hey, we have the World Cup coming up, and we want to do this fun app that everybody gets to have on their phone that will show the wave on their screen as they're part of a crowd. We just need everybody to have it real quick. You have 6 weeks, go. I'm like, all right, this is fun, this is fun. So if you're doing an application for Christmas, you probably want it out there pretty quickly because you need to have exposure in the month of December. And here we are in August, and how long do you have? And so I may not choose the cross-platform compiled approach. I might choose a hybrid WebView. Maybe for an event or something special. Although, for just regular apps out there, this is also quite popular. Just to define what it is for those of you who don't know, it can be any kind of app except the Windows Phone, rest in peace, that wraps HTML and CSS in a native shell. So it's a little bit more advanced version of a website because it actually just has some native APIs that you can gain access to. All right. So while it's installed like a native app, the views are built with web technologies that we all know and love, right? What's cool about this approach is its flexibility. So you can code locally, or you can use a third-party service to build rapidly. I've done that many times. You don't even need a Mac to build for iOS anymore. There are services that'll just render your .ipa file for you, or a couple of these frameworks themselves. It's pretty nifty. Now, you might need a custom IDE or plugin environment, but not always. Sometimes you can just use Bash. It really depends on your setup and the framework that you choose. First off, the turnaround time is incredible for this. I'm talking about building an app in like 20 minutes kind of speed, and I have done that many times. And that's before AI got involved. That was before. So that's pretty decent, wouldn't you say? Many frameworks offer remote builds of your code for each platform, which is super convenient. You also get to use your favorite front-end styling and DOM elements. And is anyone here familiar with Ionic? Okay, one person, great. Well, let me tell you, it's got some beautiful default templating. Like if you are not a designer, you just want it to look nice, they've got some really nice default styles for you there. As a backend developer, I love that I can just pick a template and it looks legit. The Ionic community in particular offers pretty decent support for each other, which is always a plus when you're diving into a new framework. But it's not all sunshine and rainbows. Let's talk about some of the downsides of doing the hybrid web view. Those remote build services, they can get pretty pricey, especially if you're doing a lot of them, which you should be because we're all good test-driven developers, right? That's what we're doing. Yeah. For some reason, in mobile, we tend to really wait till the end to test anything. I don't know why, but we just tend to do that. At this point now, I'll just do a default template and ship it and have it go all the way through my CI/CD to my beta testers and say, did that work? Do you have a default app? Great. And then I go back from there. But not all of us do that because we get excited at a hackathon over a weekend and then it gets away from us. So access to device features can be pretty limited. It has gotten better over time, but when I first started with Apache Cordova, which then was called PhoneGap, you were pretty much limited to camera, keyboard, accelerometer, maybe GPS. That was it. They're improving, but it's still mostly like common hardware features. And here's the big one, performance. You can usually spot a hybrid app by how it handles. I can usually tell. Swiping or zooming, general responsiveness can feel sluggish by like just microseconds. But we're so familiar, it has a little bit of like that effect. I'm like, that's kind of lagging. Why is it lagging? A native app doesn't do that. Even the cross-platform compiles apps do not tend to do that because of how they're built. A lot of this comes down to the device's built-in browser and its JavaScript engine. Yay. Hybrid apps have the highest probability of getting rejected from the App Store. Apple and Google prefer native apps, and partly because they want consistent navigation experiences, partly because they love control. And so if they can force you to use just their native APIs, then they will. And they can usually tell if an app was built with a hybrid framework. So while hybrid apps can be quick to develop, you need to weigh those cons really carefully against your project's needs and your target audience's expectations. Sometimes it doesn't matter. Sometimes I just really need to get something out there. For example, if I was building an app for this event, I would build it in Ionic because it would be very fast, it would look pretty nice, and what I'm trying to do still requires a round-trip call to the server for most of what I'm doing anyway, because sometimes the talks move and different people come in. So I'd rather have the most recent, and instead of having to worry about pushing things down to the native app, I can just use it this way. And of course, I already talked about a couple of these, but some of these examples are Apache, Cordova, and has anybody used Titanium? No? It's pretty fun to go back, and I still use the Intel XDK one occasionally. Nothing wrong with them, but this is the situation where you need something fast, in my opinion, because I have had years of trying every single approach out, and it hasn't really crossed that threshold for me yet. It's great for prototyping for sure. When I have no time, this is what I do. I can do it really quick. I can put it on a phone. I usually don't choose this for gaming. And there's a lot of built-in performance enhancements that can be done when you go native that are just worth it. Right now, mobile app development is dominated by React Native. Big surprise. Flutter, Xamarin, which is Maui, and Ionic, with React Native leading the pack with a 42% market share. And that is pretty beloved by the JavaScript community, and it is pretty decent. So if you haven't tried it, please do. So this is a chart that's broken down into 2 slides for you to kind of give you an idea, hence why I gave you the URL in the beginning, so you can look at it later. But this is pretty much what I look at when I'm trying to decide what aspects of my constraints are important for this app. And it kind of goes right down the line to what UI components can I use. That's often one of the biggest weights for me. And of course, do I need the direct native API access to the device itself? Overall, I mean, they're all pretty decent for what you need to do. I've never spent so much time learning a language as I did for Flutter. But it is very beloved as well by the mobile community. People who've ported over from multiple different languages really like Dart. You should try it if you haven't. Which brings us to mobile web. When I say mobile web, I'm really talking about PWAs, progressive websites. Okay? We should all be doing this already. Right, we are. 2 heads nodding, right. You know, I've been looking around your town here in Copenhagen, and I've noticed many websites are not responsive. Even now, in 2024. It's actually gotten so bad, some browsers are now asking, do you want to make this mobile? Like, we'll give our best shot at trying to make this mobile for you. It usually doesn't do a great job rendering it. But at this point, the browser is just taking matters into its own hands, slicing and dicing content in areas you do not want. So the problem is it's very opinionated about content placement and scaling. But the good news is that everybody can access these sites without installation. You don't have to worry about jockeying for position as being one of the 500 apps on your phone. You can just always access it. You can always just get to it from whatever web address. You can develop this on whatever device you want. I have a MacBook Pro right now, but I've certainly had plenty of Windows machines. And yes, you can even send push notifications from the web, though it's a bit limited in what you can do and on what operating systems, but it is possible now. It doesn't require download, which is a pro, and it's created with responsive HTML, CSS, and JavaScript, which means that probably most UI, UX people know what you're talking about. You can emulate a lot of native look and feel with this design now, and it usually integrates pretty well for data handling because it's not really on the device at that point. Everything's going to be server-side or in the browser. That's pretty huge. There are libraries now that let you add mobile app-like features that I really like. I can't think of one off the top of my head, but I know you can do touch detection, swipe gestures, everything, really make it feel like something you want to use. You don't have to go crazy and trick users into thinking that it's a native app, but you can certainly enhance their experience. But you know, touch response is typically slower because that's the way that it goes. Again, JavaScript engine. You're at the mercy of internet connectivity between your pages if you haven't loaded them all, which you might have, but let's say you didn't, and it can affect your performance. There's also limited libraries for accessing those device features. And another big one, you won't have the SEO benefits of being listed in the App Store or the Play Store. For the app I'm building right now, it crushed me because I just really wanted it to be a progressive website. But it can't, because the competition that's out there all lists theirs on the Play Store and the App Store, which means they're looking for the highest ranked, most stars, least amount of complaints. And that's how the users organically would find this app, which means I got to do it. Otherwise, this would have worked really well for me, but it's not going to in this case. And while we can do a lot with web, we can't fully replicate the native app experience. But, I mean, we can do a lot. It kind of depends on what you're trying to build. Despite these cons, for many applications, especially those that don't need a deep device integration, a mobile web approach can be a great choice, and I want to say 75% of the time. So we're going to talk mostly just about the last 25% where, yes, you do need a mobile app. All right. Some of you have gotten in your head which approach you're doing, right? You've made the decision. Great, let's conquer it. I guess I should let you look at this picture because I thought it was funny. All right, let's tackle a question that sparked more meetings in my mobile development career than any other. What do we do with the data? As you can see on our slide, we have three main options. You can live on the server, you can live on the device, or you can sync it and have it for both. If you go with the device, it might seem appealing. You think, I'll just miniaturize my .NET application and use SQLite. Done. But pause for a minute. Consider how much data you're dealing with and how often it's being edited. Local storage is not always the best solution. The third option, which is syncing between both, is often the most flexible but the most complex. This is the approach that they do for your banking apps most of the times. Tools like, man, there's so many. You can use Firebase, you can use a bunch of different services on Azure. It can make this easier, providing real-time database structures that are relatively light. But the critical question to ask is syncing even necessary? In the case of our calculator, I don't really care about saving every single time I used it. But I might care about the next bank transaction, syncing that. But do I need to sync all of the bank transactions every day? Or can I cache some of them and then only look for the diff? This brings me to how I define a mobile app truly. Can it work offline? Should it work offline? Many banking apps cache only your username and nothing else. So I spend a lot of time on airplanes. And while some of the companies that I fly on do provide Wi-Fi, if it works, it's very spotty. And often I can't get things synced from my bank. It's very frustrating. So for the app that I'm creating, we will cache that offline because you can do a whole lot with protecting it on the device now with biometrics. There's a lot of options for you now. I'd rather spend the time while I'm in the air, bored, reconciling my bank transactions than waiting to try to land and syncing them. So keep this in mind, the usability aspect. Where are the data calculations and business logic handled? The decision can be divisive. A team I worked with previously, many of the mobile developers insisted on handling all of the business logic in the app. That's where they wanted it to be. It's where they were comfortable with it to be. They wanted to control everything beyond basic data retrieval. There are cases where this totally makes sense. Anybody watch a solar eclipse in the past couple of years? Yeah? Yeah. Well, there is an app. I used one earlier this year in the States. And it uses the phone's location and accelerometer to determine if you were in a totality zone, all offline. It didn't need to be synced. That's a great example of when to keep logic on the device. That's when the engine should live right there. However, most of the time it's unnecessary and inefficient, and it makes the app huge, and then people will uninstall your app. And so we don't want that either. Putting logic on the server often makes sense for the complex calculations or when you need to maintain consistency across iOS and Android. That way you don't have to write any separate code for either one of them. Then there's the third option, using third-party APIs or installed applications. This is a powerful approach that's often overlooked, but it wasn't by the TSA. So in the States, we have an option to re-enter the US as a citizen in something called the CBP mobile app. And that mobile app, instead of accessing the camera directly and putting it in there, it let you just choose whatever camera app was installed. And you could decide if you wanted to use the default. That means that was less work that they had to do, and all they did was say, give me the default camera app and take a picture and give me the picture. That was the extent. Instead of manually handling all of the UI elements with the camera, which was just more work. But often we forget that maybe there's another app that could have just done that one step better, and we can just pull in the results. How do you want to create the user experience and interface? As you can see, we've got two approaches. One common UI, UX to be shared among the platforms and coded separately per platform. The first approach, using a common UI, sounds great in theory. Frameworks like Xamarin and now Maui allow you to write once and render native controls across. But there's a catch, okay? When a major hardware change comes out on the new Samsung or iPhone, suddenly the controls look different and take up different amounts of space. And so now everything is below the fold and the product owner is not happy. You end up having to override and separate the UI anyway to accommodate these differences. It's like back to CSS all over again. So then there's the issue of device size, from tiny phones to like phablets. These in-between sizes are too big for your pocket, but not quite a tablet. They each require consideration in UI design, therefore you should separate that out. When deciding your approach, you have to consider your app's complexity and the importance of a consistent look across all platforms, or if you're just going to say, you cannot install this on a tablet, sorry. That's an okay constraint. However, in my old age, sometimes it's too small, and I want to put it on a tablet just so I could see it better. So remember who your users are. There's no one-size-fits-all answer, but understand the trade-offs. Now let's talk about a crucial aspect of mobile app development that often gets overlooked: security. Because as the saying goes, you never know who's out there with a slingshot aimed at your app. At my previous company, we were fortunate to have an ethical hacker whose job it was to break into our apps and find vulnerabilities. It was pretty fabulous. But I know that's not the case for everyone. If you're working solo, as I did for many years, thinking about all the ways that the data could be stolen or your app exploited can be pretty overwhelming. When we talk about weakness, it's not always about catastrophic data breaches, although that does get the media time. Sometimes it's as simple as a cheat code in a game. So if you built a game and maybe you didn't really conceal that too strongly in how you created that, and all you need to do is just increment a number, that's one way. Imagine you've created the next Angry Birds. Someone reverse engineers your app to get extra points, and suddenly they know how to do that. It may seem harmless, but it's still a form of hacking. The good news is you don't need to hire a full-time ethical hacker. While there are freelance ethical hackers on like Fiverr and Upwork that would be delighted to try and break your app for you, sometimes you can just simply give them access and ask them to find vulnerabilities, and they think it's fun. The growing market of ethical hackers is an excellent resource for us. And have you done any ethical hacking in your own time? Yeah, a couple of them. It's super fun. I appreciate it. So as you develop, just keep security in mind from the start. It's about protecting your users and your hard work from potential threats. Remember, when you're storing things on a device, please encrypt it. Then you've got to discover where the weakest links are. This is the fun part of our job, right? The one we spend the most amount of time on. Usually it's ground level. You know, the stuff you wrote in the beginning usually has your weakest links because you didn't know as much and times have changed and things have just gotten more complex. It doesn't make sense that it would be that way because we spend all this time preparing for it, and then once you build it, you leave it alone and you never check if the way you built it before is still secure. For some reason, when we build an app and we ship it to the App Store, we're like, go make money. Bye. And unfortunately, you have to be very proactive with ensuring that the way that you built this will still be secure for years in the future. You could do a couple of approaches to this. You could incrementally test your code as you go. In the platform emulator on your IDE, it's free. That's good. Or you could plug your device into the computer, and it only costs however much your device costs. You could distribute it to beta testers, which is also free in certain platforms like TestFlight for iOS or Google Play Developer Console. Or you could use a paid service, which is something that I use often. The pricing does kind of vary. I've used a whole bunch of them, and it's helpful because they often can have more than one device, different ages, different brands. Sometimes they'll specifically have ones that are bloated, that have the 500 apps so that you kind of understand what performance you're up against. That's pretty cool. I'm going to tell you a story. I once worked for a company that was contracted to build an internal application. We decided to use a new cross-platform framework that had been released in beta, and I will not tell you which one it was. Excited by the possibilities, I convinced my team that we could build this app in 6 weeks. We managed to create something within that time frame, but we hit a major snag. An app that we built would constantly crash on Android users after the first uses. Not the first time, not the second time, but like after a few. And Interestingly, it worked totally fine on iOS, but I just chose this cross-platform compiled framework. Shouldn't it work on both? This was a big problem because our client was heavily invested in the Android platform in another country. So I was really desperate for answers, so I reached out to some developer advocates at the company, and they revealed a crucial detail about the app that we built. This new cross-platform framework had to juggle two different garbage collectors, one for .NET and one for Java. These collectors handled objects differently and on different timelines. So once we understood this, we changed our approach. Instead of constantly redrawing our screen, which is what happens, at least at the time it did, every time I wanted to show a new menu or a new screen, we just reused objects and updated the content within it. That solved our crashing problem. But here's where it gets worse. In my desperation to fix the issue, I had tried switching between garbage collectors and even attempted to write my own, through this whole process. Pro tip, don't do that. There are smarter folks that do this professionally. And I ended up crashing the iOS version 2 in my haste to try to figure out the garbage collection issue. And we missed our deadline completely for that one. This experience taught me two important lessons. Always research the potential pitfalls for each section that you're building. So if your focus right now is on authentication, really research the pitfalls that come with that. If the next part is, okay, we need to do a lot of forms-based stuff, look into the pitfalls for that piece of it. You need to look at each piece before committing to these frameworks for large projects. And sometimes the simplest solution, like going native, might be more cost-effective in the long run, even if it didn't seem like it initially because of these kinds of things. Just thought I would share that fun with you. All right, let's talk about the final hurdle. We're publishing your app. It's tempting to think, my app is done, let's throw it out there and see what happens. And I'm very tempted every time to do that because I'm very excited. But hold on. The publishing process is pretty crucial and deserves careful attention. First and foremost, read the contract thoroughly. As a developer on the Apple or the Google platforms. This isn't just a formality, it's about ownership and legal requirements. You might be surprised to learn that if you don't read and understand the terms, you may not even own your own app. This is especially critical when you work for large companies. The publishing landscape is always evolving. For example, in voice app development, Amazon would update its Alexa documentation so frequently that I had to just constantly reread it once every couple of months. Just stay on top of the updates or assign them to someone in your team to track them. And here's a key point to remember. Rejection is normal. In fact, it's almost guaranteed, but don't take it personally. It's part of the process. Your app, which you've poured your heart into, will likely be rejected on the first submission. It's kind of a rite of passage for developers. Has anybody here published an app that was never rejected? Right, exactly. So how do you plan for this? Don't wait until the last sprint to submit your app. I can tell you that much. Build buffer time into your timeline, weeks to months. I typically plan for 3 rejection cycles. This allows time for the initial submission and the rejection, making changes and resubmitting, and potential further rejections and modifications because you didn't read that one part of the terms and conditions. All right. I'm going to walk you through this mobile architecture decision tree that I came up with, or MAD tree for short. It's a simple yet powerful tool that helps you decide which mobile development approach is best for your current project. Because remember, you should decide this based on the project, not just because it's what you're comfortable with, although that could be a factor. This tree asks 4 key questions. Are you on a tight budget? Does it need constant internet connectivity to work at all? Will it have offline functionality? Will it need to access device features like cameras? And it kind of guides you in the direction you need to go. Native is best for apps that need full device feature access and offline functionality, but it's typically more expensive to build because you need twice as much time. Cross-platform compile is the good middle ground that it can access device features and work offline, while potentially being more cost-effective than native development. Hybrid webview is suitable for apps that don't need extensive device features, but still require some offline functionality and the ability to be in the App Store. It's often more budget-friendly. And of course, the most cost-effective one should be mobile web, ideal for projects that mainly require connectivity and don't need any device-specific features or offline functionality. This tree is a guide, not a strict rule. But I get asked these questions all the time, and I figured that this might be a nice little graph for you. The beauty of this diagram is its flexibility. It helps you just consider things. And I often will go back and look at it myself for the next project. Some parting advice: you must plan your approach. Small or large, you have to plan it. You can be agile, but some initial planning is crucial. Know that your app's purpose is going to be this, and have a rough idea of screen layouts before you even start with the very first one. If I'm developing an app that is going to be more immersive, I'll go native every time. Why? Because performance is critical when you're constantly challenging the phone's graphic card. You need that. And if this is your first mobile app, just create a proof of concept. It doesn't need to be elaborate. Just aim to build something. Keep it small and to the point and not large. Allow room for growth, not complexity. Be mindful of how much you're using the internet. Allow several weeks for app submissions. Measure 10 times. And submit your app once, because rejections are swift and sometimes hard to reverse course. Stress tests on low signal strength networks. I like to test mine out on 3 ways, like Wi-Fi with just my telco and in airplane mode. See what happens with each of them. Take a field trip to the countryside if you need to. Go see if your app breaks in areas with poor connectivity. Separate your must-haves from your nice-to-haves, because you will cut them, at least the first 2 or 3 versions. The best approach is the one you completely understand, so you can unwind it if it doesn't work. I have rebuilt an app 3 times, but at least I understood why it didn't work as I was building it. This is really hard if you're moving from just back-end development into mobile. You haven't had to really think about a lot of these. And just don't get sandboxed. You have to test often and early to catch your mistakes. I will close with this quote from Charles Hoare. There are 2 ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that there are no obvious deficiencies. And the first method is so much more difficult. Remember, attention to these details can make the difference between an app that succeeds and one that struggles in the real world. If you're interested in getting this deck or talking to me afterwards, you can find it on my SlideShare. Thank you so much for staying for my presentation.